Hello and welcome to my channel EPSC. Today I will give you the idea about how to read and understand the PNID. So like we know the full form of the PNID. The PNID is a piping instrument diagram. So this PNID was prepared by the process department. PNID is just a single line presentation diagram which give you the idea about all the components comes in the process line, like piping components, instrument and equipment. This is the single line diagram presentation which made by the process department. It give you the idea about how the line is connected between equipment to equipment and what the component should become in the line. This gives you the full idea in the PNID. We have to just understand that the pipe is just used for a fluid transportation from one place to another place. It means the fluid should be transferred from equipment to equipment with the help of pipe and some piping component on that line. Most of the main thing is in the pipe, fluid is not converting any other disciplines. Like fluid is changes from the equipments. If like I take example like air separator. The air separator is separate the air and the fluid go ahead. If I take a compressor, the gas is get, if I have some a fluid as a gas and the gas is get some air also, so the air is get compressed and the gas go ahead. If I have a heat exchanger, the heat exchanger means the cold water convert into hot or hot water convert into a cold, and the pump which I use have to push a fluid from one point to another point in certain time. So I use a pump. The pump, the discharge is give me a velocity and give me a speed. With the help of the pump, I can reach in what time I have to need a fluid in some other equipment. If I take a boiler, the boiler is means convert into a hot something. Furnace also its conversion is a hot. Storage tank is just a simple storage tank. The main thing in the PNID reading, you have to know about the equipment. What equipment is converting the fluid? The main is equipment. The pipe is just a helping of fluid from one point to another point. You have to know what exactly this pipe is used for. We have to use a pipe is just for transferring a fluid from one place to another. The main person in the refinery is the equipment who convert the fluid in another fluid or another purpose, like what is required. You have to go ahead. Everything is like, if given the example of like air separator, compressor, heat exchanger, pump, boiler, furnace, and different kind of more equipment it should be there. But the main conversion is make equipment only. The pipe is just helping us to take a fluid from one point to another point. If you see, this is the instrument. This is the PNID. Okay, so you can see a lot of things are there. The line number, the PNID representing the line number. Okay, the instrumentation also, instrumentation are there. The connecting instrumentation are there. So what in the line, what are the components are there, connectings are there. So you can see equipment over here. Okay, this is a heat exchanger. It gives you the idea like how the things are connected. Okay, how the lines are. This is the flow arrow. Okay, from where the line comes and when the line is getting connected. So this is the line, and this is the lines coming from where. So this is a PNID number. It gives you the idea. So this is a PNID number, okay, and this is some like a connections are there, okay. This is the instrument connection, okay. It's a 2-inch, is given the size 2-inch, and again we go ahead, okay. So there is some drain out there, again instrument items. This is some of the, this is a valve, it's 8-inch, again is a valve 8-inch, and this is something like a control valve assembly are there, okay. So this is like PNID means is give you the whole idea about a piping component, instrumentation, where instrumentation are required, where is not required, okay. So it give you the idea about the flow indicates from where the fluids comes and is go into the heat exchanger, okay. This is like just a presentation. It's not means like if they have route like this way, the layout should be also the same. No, we have to see our equipment layout, and then we can route the line as per the our layout. I go to the next slide. This is another PNID. This is a equipped vertical vessels are there. This is a, here is a control assembly are there. This is a bypass connection, okay. Before the bypass connection, see, you can see here the line coming from some another PNID. You have to know, like this is a, this line from the top, the lines going outside from this PNID and connecting to this another PNID. So you have to, this is a one PNID number, okay. It's a 0845730. So you have to check this line number, this PNID number, and we have to check this line number from where this line is going to the this PNID and connecting to some other equipment or some other headers, okay. So you have to know, like this is a right, where we can understand the PNID. So you have to just understand one PNID, okay. So the main thing in the PNID, whenever you are getting a PNID to read or understand, so what do you know, like what we understand, like if you have a lot of components in the PNID, like if I take this component, so what is this component, what is this diagrams say to me, and what is this, so, and what is the line number, it gives the idea. So we have a legends, okay. We have the legends where all the components, they gives the naming. If it's a gate wall, a wall, a globe wall, and the line, it gives the idea about the instrument line, process line. It gives the idea about installation. It gives the idea about the instrument indicators. So all the abbreviation of the symbols. So we have to use a legend sheets, okay. In every project you will get a legend sheet which you can refer to know what the symbols are there. So this is the legend sheets where you can get in the project. So this is the left side, you can see this is all the like process line, instrumentation line, hydraulic lines are there, okay. You can see electrical tracing over here, system and condensate tracing. Here is given some or more idea about that. This is all the instrument symbols, okay. These relief wall symbols. This is all control wall, or most probably the legends gives all the idea about all the piping component, instrumentation items. It gives you the instrument signal indicator, also give you the idea. It give you the assembly for the stream trap and whatever this in the PNID this gives in the PNID. So they gives in the legends also. So you can see the next slide is give you the idea about the equipments also. If you get small special items is connected into the line, so it shows you like what exactly it's in the equipment legends are there to be used in the line. You can see this is a process flow line, pneumatic line, hydraulic line, alternate line, insert gas line. So this is the line type we use in the PNID. So it shows in the legends. And what it means, like piping system. The piping of the single system may contain more than single medium. For example, all the main process flow line may carry water, the associated auxiliary piping may carry, and this gives a more idea about what it should be. So this gives you the idea like what line type is stand for. So these different line types. See, you can see a dotted line. So it gives you the idea about the instrument signal line. Okay, this is the instrument capillary. Different. See, you can see the process line are there. Okay, under the process line is give you a E. So E means electric heat tracing, and is give you a S. So is give you a steam heat tracing. So you don't have to search in the Google or somewhere. You have to just go on the legend sheet and you have to just check it out. What the line type is say you. Okay. So this is wall symbols you find in the legends. This is the way. This is just a different sample I have copied from the Google. Okay, and I just give you the idea so how it should look like. So you can see this is a globe wall, this is a normal wall. Okay, this is gate wall. So this is not fixed. The wall, the symbol, it should be standard in every company. So it depends whatever the wall is should be they take. Okay, and main thing in every project we have to consider a legend, what a wall stand in the name of. Okay, you can see this is a wall actuator. Okay, this is a diaphragm, alternative electric motor, solenoid, alternative piston, alternative. See this all, and this is a manual control wall designations. So you can see this is a flow. F stand for flow, T stand for temperature, L stand for level, P stand for pressure. Okay, H stand for hand operated valve. So you can see over here, this is a flow control valve, temperature control valve, level control valve, and pressure control valve. This is an instrument identifier, the sensor parameter like flow temperature, okay, pressure temperature, current level, voltage, position. So this is the FIC, means flow indicator controller. Okay, and this is a flow meter, flow modifier, pressure modifier, temperature element, temperature recorder. So this is all the items which comes into the instrument items. So this gives you the idea. It's like continuation symbols is used, like the lines. This means the line goes from this PNAD and connect to another PNAD. This arrow means the line is coming from the another PNAD and connecting to this PNAD. And this means the 5 OI is continuing on the drawing. The grid coordinate XY flow in the both direction. Okay, the line is going on the both direction. This is a area. This is building an area bound. This comes like vendor package line, or this line is it means like it is just a building area or boundary. So this is just like a kind of PFD. It's just you can see this tank is given, the two wall, one wall. Okay, this just show you, okay, the line is coming from here and connecting to here, but it's not give you more idea about the instrumentation, also not more components.